crystal clear waters of East Asia are home to more species of corals and reef fish than anywhere else on the planet. Some of the rarest and most exotic creatures in the world have evolved here over millennia. In this environment, plant and fish depend on one another to thrive. From the ocean's largest creatures to tiny reef fish and brilliantly colourful coral, cutting-edge scientific research is helping us to explore and understand a previously hidden world. As we learn more and more about how these creatures navigate their ocean wild, we start to unravel some of the ocean's greatest mysteries. The waters around the Philippine archipelago are a hub for marine biodiversity. They are home to some of the world's most colourful coral reefs. From tabletop formations to wildly branching coral structures, the coral reefs of the Philippines provide shelter and food for over 900 species of reef fish, as varied and brightly coloured as the reefs themselves. In this episode, we discover a strange world of communication and deception behind the beauty of the reef. A marine language of colour and camouflage, fundamental to life beneath the waves. The waters of the Philippines are home to 6 of the 7 known species of sea turtle. As they spend much of their lives in the water, seeking out algae and seagrass to graze on, they are far more attuned than us to the colours and shapes of this submerged universe. Like the hawksbill sea turtle, it may look hardy, but it is very sensitive to touch, both on its flippers and on its shell, which is covered in thousands of tiny nerve endings. Its sensitive shell helps it to hear through vibrations in the water. Its sense of smell helps it to track down food when visibility is poor. But this turtle's greatest superpower is its superb underwater vision. Remarkably, recent studies have shown that green sea turtles can, like us humans, see in colour. They are expert navigators, and some will migrate thousands of miles in their lifetimes. Helping on longer journeys is a kind of internal compass aligned to the Earth's magnetic field. They have remarkable spatial awareness, identifying underwater landmarks to help determine where they are. As they glide above the surface of the reef, they use their colour vision to locate food on the rocks and coral below. Their eyes are best adapted for finding food in brighter, shallower waters. But sometimes they have to dive deeper to find their next meal. In deeper waters, as well as relying on smell, many turtles harness their ability to detect the faint glow of bioluminescent prey. Like many other creatures living on the reef, they are able to perceive near ultraviolet light. This sensitivity may increase the contrast of the turtle's vision, helping to identify and locate small worms, crustaceans, algae, and seagrasses in the darkest corners of the reef. Adult hawksbill sea turtles are herbivores. Their jaws are serrated to help them chew on tough stalks of seagrass. The long claws on their front flippers and their mobile necks help them to get at particularly difficult to reach meals. The coral reefs of the Philippines provide plenty of red, brown and green algae for them to choose from. The green sea turtle is just one of the creatures we will encounter that boasts colour vision. They are also not the only form of marine life which perceive colour beyond the limits of human sight. As we will see, many other creatures on the reef use this superpower to hunt for food and to map out their underwater world. These damselfish are aggressively territorial. Colour vision allows them to distinguish between neon damselfish and yellow damselfish, to tell friend from foe. They can also differentiate individuals by recognizing discrete facial patterns of UV freckles and lines. This allows them to tell the face of a family member from that of a potential rival. By contrast, the zebra-like stripes on these humbug damselfish are anything but discreet. They're deliberately bold to help mask their outline and serve to confuse predators. Coloration in fish often serves one of two ecological functions: deceiving one's enemies, like the mask pattern on the face of this majestic angelfish, or recognizing one's own species in a crowded and colourful reef environment. When trying to decipher why reef fish are so bright and colourful, we must remember that what may appear conspicuous to us may in fact be the perfect camouflage. These Laber's wrasse display a staggering diversity of colours only visible to each other. While the wrasse can see red and orange colours, many of their predators cannot. They can simultaneously recognise their own whilst hiding from predators. Some fish are able to control the distribution of their colour pigments for the purpose of camouflage. These barhead damselfish can grow black spots in the shape of eyes on their rear fins, simultaneously increasing the size of the black spot and reducing the size of their real eyes to cause confusion. The stripes on these orange-lined cardinal fish may be as much to dazzle their predators as to hide from them. Over thousands of years of evolution, reef fish have developed cunning camouflage strategies to outwit their foes. The eye spots on the tails of these black spot snapper deceive predators as to which direction they're swimming in, a good tactic when you're trying to escape from a hungry shark. Some beautiful patterns have evolved to serve purposes other than camouflage. The male clown chorus, also known as a twin-spot wrasse, is usually quite a dull fish, but when courting, he will intensify the colour of his eye spots in order to attract a mate. He wants to be the centre of attention. The crowned puffer is also a bit of an attention seeker, inflating to twice its normal size in order to scare off potential predators. Pufferfish are amongst the most poisonous fish in the world. Their bodies are covered in a toxic mucus that can be fatal to humans if consumed. Reef fish cannot rely on camouflage alone. They stay close to their hiding places in case they need to make a quick getaway. The colour of reef fish has a close relationship with the corals that shelter and sustain them. The colours and patterns on a harlequin filefish make them look like coral, but they have another camouflage technique. As they feed on the coral, they absorb chemicals, which makes them smell like coral too. This double disguise helps to camouflage them from predators like cod. When fish change their colour, it's not always a matter of camouflage. It can play a part in a more dramatic transformation. Like other anthias fish, these purple queen anthias have the remarkable ability to change their sex and their colour. All are born female, but when they transform into male anthias fish, their colours become much more vivid. The change takes approximately 2 weeks. Each school of anthias fish consists of several social harems. Each harem is led by the most colourful male. If a community of anthias fish has too many males, the fish can change back to female again to redress the balance. The reef is a world of constant transformations, where size, colour and even sex cannot be taken for granted. When it comes to staying safe on the reef, colours aren't always enough to ensure that a reef fish is safe. These blue-green chromies have many potential predators, including groupers, lionfish and eel. They don't stray too far from the coral, and as soon as they sense danger, they dart back to safety. They will only emerge to continue feeding once they're sure the coast is clear. They say that beauty is in the eye of the beholder. The same is true for camouflage, because on the reef, what matters is how colour is perceived by predators. It is only by understanding this perception that we can begin to understand the complex relationship between colour and camouflage. In some cases, we can see quite clearly with our own eyes just how effective a camouflage strategy is. It's very easy to miss these spotted gill cardinal fish. The dots and dashes along their pale yellow bodies make them appear remarkably similar to the branching coral where they rest and feed. Some predatory fish are dangerous even to humans. Falling into their trap, we can find them difficult to spot, like this venomous scorpion fish hiding on the side of this tube-shaped sponge. What may look like a piece of drifting seaweed is in fact a cockatoo wasp fish. It sways back and forth in the current, mimicking a piece of debris, waiting for its victims to get close, whether tiny crustaceans or even a fellow wasp fish. Even though they are small in size, the spines on its back are extremely venomous. Spotting a true master of disguise is no easy feat. The pygmy seahorse is extremely difficult to see. Typically measuring less than 2 centimeters long, it is one of the smallest seahorse species in the world. Its head, body, and long prehensile tail are covered by tubercles to match the shape of the polyps of its host coral. These seahorses are born a dull brown colour, but will slowly take on the colour of their chosen coral home. The size and fragility of pygmy seahorses makes this chameleon-like adaptation key to their survival. They spend their entire adult lives living on the same Gorgonian coral. But while they might look cute, they are expert stealth predators. They approach to within a few millimeters of their prey, tiny copepods, then they strike. Very sweet, but also very deadly. Some marine creatures are almost invisible to the human eye. Ghost pipefish, although common on the reef, are notoriously difficult to see. They tend to hunt alone or in pairs, among the branches of gorgonians. Floating with their mouths pointing downwards, they feed on mysids and small shrimp, which they hoover up with their long snouts. Sea urchins are good at hiding in rocks and crevices, but are hardly masters of disguise. Their sharp spines, however, do give shelter to tiny creatures who are very good at staying hidden. In return for protection from their sea urchin hosts, these tiny razorfish keep them free from parasites. They share the spines with other creatures too, like these flagfin cardinalfish, all of whom are safer hiding in the spines of the sea urchin than they are floating free above the ocean floor. Razorfish swim vertically to help them avoid touching the spines of the urchin, which in some species are venomous. Urchin clingfish, with their elongated bodies and stretched snouts, weave in and out of these spines with incredible deftness. They emerge to snatch passing prey before darting back to the safety of their spiky fortresses. Sometimes, particularly in open water, it is safer to hide in a crowd. Swimming in schools is another form of protection against predators. This school of striped eel catfish has a much greater ability than any individual to keep watch for predators. The school may even fool some predators into thinking that they are one enormous fish. This school of big-eye trevally is particularly impressive. Schooling serves to both keep them safe and to make them into a formidable hunting pack. To watch a large school of fish, like these blue-striped herring, swimming in perfect harmony is simply breathtaking. This formation is called a bait ball. It is usually a last-ditch defense attempt adopted by schooling fish. Gathering in this way shows a strong instinct among lone fish to group together when threatened. Schooling is not something fish are taught. It is hardwired in their genes. From birth, it appears many fish know instinctively how to maintain their position within a school and to move in sync with other fish, so the whole formation appears to move as one. Schooling gives fish many other advantages over a solitary life. For one, it is easy here to find a mate, and traveling in a group of other fish allows them to move faster through the water, achieving better hydroefficiency, just like a V-shaped squadron of birds flying through the air. While schooling does offer greater protection to the group, any individual fish that stands out from the school is likely to be targeted by predators. Some predators, like this pelagic thresher shark, have developed aggressive counter-strategies to schooling. Its vision is 10 times more sensitive to light than our own, so that it can track its prey even in the dark. Its sophisticated understanding of how schools behave allows the thresher shark to steer the fish into a compact mass. Once it has the school of fish where it wants them, the fresher shark prepares to unleash its secret weapon, its whip-like tail. It will attack the school before picking the stunned fish out of the water. Yet schools of fish react quickly. Individual fish can detect minute changes in water pressure caused by both predators and other fish in the school as they change speed and direction. This means that schools are able to perform impressive evasive maneuvers, giving the majority of the school their chance to escape. Distinct markings and colours can often help in identifying other predators lurking on the reef. Bright, bold stripes often signal danger. The neurotoxic venom of the banded sea crate makes it among the most lethal creatures in our oceans. Its venom attacks the nervous system of its victims and is 10 times more powerful than that of a rattlesnake. In humans, a bite can result in convulsions, paralysis, cardiac failure, and even death. While not dangerous to us, the ribbon eel is a brutal, opportunistic stealth predator. These carnivores prey on small fish and crustaceans, which they attract by twitching their magnificent flared nostrils. Once their prey is in range, they clamp down on them with their strong jaws and retreat back into their burrows. As they grow into adulthood, they turn from black to blue color and are even more deadly. We humans in the past have often misread the language of camouflage with dire consequences. With its elaborate patterns, the red lionfish was once a popular aquarium pet, but we underestimated this brutal killing machine. In fact, red lionfish will trap their prey in corners of the reef and swallow them in a single mouthful. It is believed they were first introduced into our oceans by fish hobbyists. They multiplied quickly, causing a population boom so great that it is one of the worst marine invasions in history. With few predators, they have been near unstoppable on their rampage through coral reef after coral reef. Coral Triangle is sometimes referred to as the Amazon of the seas. Like rainforests, the coral reefs of the Philippines are particularly full of color. The colors depend on a variety of factors, from the geographical locations of coral reefs to the kind of marine life they play host to. Some of the most colorful life forms on the reef are sea anemone and their symbiotic partners, anemone fish. A sea anemone is a predatory animal in the same family as the jellyfish. Their column-like bodies are topped with a ring of tentacles surrounding a central mouth. Touching the tentacles triggers the release of a harpoon-like sting. This injects a dose of powerful neurotoxins into any small fish unlucky enough to brush past. Except in the case of anemone fish. They have a mutually beneficial relationship with sea anemone. The anemone fish ward away predators and get rid of parasites, in exchange for protection within the anemone's tentacles. Also known as clownfish, their bright colors are thought to help lure smaller fish for anemone to feed on. They aren't particularly agile swimmers, but they will chase away any invaders who trespass on their patch of anemone. They are very picky when it comes to finding a mate. In captivity, females have been known to kill any males they find unsuitable. Anemone fish are not born immune to sea anemone stings. They cultivate their resistance by rubbing their bodies up against their hosts, building up an immunity over time. Thanks to their distinctive uniforms, the anemone fish can quickly distinguish between friends and potential rivals. Another creature with whom they and the anemone share a symbiotic relationship, anemone shrimp. These are tiny, almost transparent crustaceans which feed on algae, parasites and plankton on the surface of the anemone. Also known as cleaner shrimp, they have a special relationship with anemone fish. You can see how they've earned their nickname. Cleaner shrimps eat tiny parasites from the skin of the clownfish. The reef is full of these unlikely alliances between very different forms of marine life. Many of them, like the relationship between clownfish and sea anemone, are mutualistic, which means both organisms benefit from their alliance with the other. Some of these relationships are themselves a form of camouflage. The anemone hermit crab gathers up anemones and attaches them to its shell as a kind of disguise. Hitching a ride allows the anemone to travel between multiple feeding locations. For the crab, sporting sea anemones on its shell is also a form of self-defense. The larger crab seems to be weighing up this shell for himself, but it appears as if it's already occupied. With no anemones to keep it safe, the smaller crab is vulnerable. But in the end, the fight isn't worth it. The larger crab seems to be content with its own shell. The waters of the Philippines are warm and stable all year round. This means that fish can mate and spawn throughout the year. Colour plays an important role in how fish on the reef find and choose mates. Colour actually forms the language of love. Strapweed filefish can change colour to match their surroundings as a form of camouflage, but when courting, they can also change colour to attract a mate. Colour change in male strapweed filefish is accompanied by a display of manly prowess. The male wiggles the first of his dorsal spines and stretches his ventral fin out wide. Males perform this dance in the presence of female strapweed filefish to compete for their attention. Some males, on the other hand, resort to brute strength to intimidate their rivals. This is a carpenter's flasher wrasse. The females are a modest orange colour. The male is a deeper shade of red. In the presence of females, he flashes his fins and intensifies his colour. To really impress females, he hovers vertically in the water, stretching out his fins in a kind of underwater handstand. Hiding in this forest of branching coral are fish with very particular mating habits. The mandarin fish, so called because its vivid coloration evokes the robes of an imperial Chinese mandarin. They're usually very shy. They move slowly and keep close to their coral hideaways or to the ocean floor. But during courtship, the mandarin fish becomes a little more adventurous. It's dusk. They have only a small window of opportunity. The daytime hunters are slowing down, and the nocturnal hunters are still asleep. This pair are seizing their moment. They seem to dance together, the female resting on the pectoral fin of the male as they waltz slowly over a metre above the reef. At the peak of their ascent, they release a cloud of eggs and sperm before racing back to safety. The charming but brief mating dance of the mandarin fish is over before you know it. Camouflage on the reef is not just a matter of hiding oneself. Some species of fish must find innovative ways to protect their eggs from poachers, like this carnivorous yellow trumpetfish. Sea snakes will also gladly eat up any fish eggs they can find under rocks and in the crevices of the reef. No matter how carefully concealed the eggs may be, many parents have no choice but to remain vigilant. This fiercely protective golden damselfish will attack any intruder that comes close. They lay their eggs in the branches of coral. The black spots you can see are the developing eyes of the young fish. They are almost ready to hatch. Anemone fish use their relationship with the anemone to conceal their eggs more effectively from predators. This Clark's anemone fish is putting a lot of effort into fanning his eggs. It's exhausting work, but he must make sure his eggs are well aerated and have a fresh supply of clean seawater. Fanning the eggs helps to promote their growth and keeps them free of mold and bacteria. This anemone fish is also protecting his eggs. He has chosen a secluded sandy spot beneath the anemone to keep them safe. He will stay close, carefully fanning the eggs to protect them from sediment until they hatch. Some of the most striking colours on the reef are those of the coral itself. They may look plant-like, but they are, in fact, animals. They are colonies of thousands of individual organisms called polyps. The polyps secrete layers of calcium carbonate beneath their bodies, and over thousands of years have formed the reef structures we see today. Coral have a close relationship with plant cells, or zooxanthellae, as they cultivate plant cells for food, providing coral polyps with up to 90% of their energy needs through photosynthesis. These plant cells are partially responsible for the colourful appearance of coral. This is the drop-off, a vertical wall at the edge of the reef, which plunges into the depths of the sea. The coral here thrives in the nutrient-rich water, rising up the cliff face on currents from the ocean floor. Fish, too, gather around the drop-off to feed on the plankton and to find shelter, like this solitary bluefin trevally. The red-toothed triggerfish is one of the most stunning residents of the drop-off. They feed on plankton borne by the upswell and take cover in crevices and under ledges when the current is strong. As we venture a little deeper, we start to encounter some of the reef's weirdest residents, like this giant anglerfish. Who better accustomed to life in the dark? We are deeper and darker here than many reef fish will venture, but some have adapted to life in this eerie twilight world. Even at lower depths where the light is dimmer, methods of camouflage are vital to a fish's survival. The bright metallic sheen of these sweeper fish is due to a system of reflective crystals in their skin. As they swim upwards, the crystals scatter light from the surface to dazzle the sweeper's predators. By night they forage for zooplankton. By day they seek shelter in tunnels and caves, such as this one. Sweepers often share hiding places with other fish, like this school of pygmy sweeper. They're well adapted to life in the dark, with unusually large eyes. Some sweepers that make their homes even deeper are covered in luminous spots, called photophores, to help them attract prey. These fish may think they are safe, but there is an uninvited guest in their tunnel. A master of camouflage, the giant frogfish can change the color of its skin to match the sponge on which it lives. Giant frogfish are covered with thorn-like spines and little warts. They also have an impressively elastic jaw, perfect for a voracious carnivore like the frogfish. They eat whatever comes their way, including lost sweepers and even other frogfish. In the dark, some animals reveal hidden talents. Electric flame scallops or disco clams seem to surge with electric light, but this is actually flashes from tiny bits of silica. The flashes are a warning. Touching their toxic lips can release a jet of sulfuric acid capable of inducing a catatonic state in an unlucky predator. This impressive cave structure near Pescador Island in the Philippines is known as Cathedral Cave. Here, we encounter more creatures putting color and camouflage to good use. The box crab derives its name from its ability to compact itself by tucking in its legs and folding in its claws. In this box-like shape, it can bury itself almost entirely. The only thing still visible is its eyes poking out of the sand. In the gloom of the cave, some creatures, like these barber pole shrimp, use especially bright colors to attract attention. They wave their antennae in an attempt to lure eel or fish. They aren't predators. They are, like real barbers, simply advertising their services. They feed on algae and parasites that grow on other fish's skin. Bright colors can stand out in the darkness. White-spotted pufferfish can be found at depths of up to 35 meters. They have the ability to darken the white spots that cover their bodies to match the light levels of their surroundings. Like the white-spotted pufferfish, large-toothed cardinalfish are nocturnal and look for dark places to hide during the day, in caves or under ledges. The yellow-brown stripes on their bodies are perfect for camouflaging them in these low lights. Cathedral Cave provides excellent hiding places for its residents. By contrast, those who make their homes on the ocean floor must rely on more ingenious camouflage techniques. Fingered dragonets travel across the ocean floor by literally dragging themselves along. They're covered in the same mottled colors as the sandy bottom, so as to move about virtually unseen. Gold-specks jawfish, with their characteristic bulging eyes, construct burrows to hide from predators and ambush their prey. Sight is not a gift shared by many species here on the ocean floor, but those who cannot see often come to an arrangement with a creature that can. Yellow watchman gobies, for example, have a close bond with their pistol shrimp partners. The goby cannot dig a burrow itself, but the pistol shrimp can. In return for the pistol shrimp's construction work, the goby acts as a sentinel. Through the shrimp's antenna, the pair are able to stay in constant contact. If the goby spots any danger, they both retreat to the safety of the burrow. These common fuse goby have paired up to dig a burrow together. They use their mouths to skillfully scoop up and spit out the sand. They make their homes with a small entrance so that they can cover it over at night. This helps to keep them safe from predators. Building burrows and other structures is not something we necessarily associate with fish, but tunnels and burrows are key camouflage techniques essential for keeping bottom-dwelling fish and their offspring safe from harm. The common fuse goby is known for its careful nesting habits. It is the male who plays the role of attentive parent. He must first brush the sand off a suitable rocky surface to create the perfect place for a nest. Once the goby has prepared the nest, the eggs are deposited by a female. His eggs need to be kept well supplied with oxygen. The goby fans them with his fins to keep the water aerated. Without this attention, the breathing eggs would use up all of the oxygen in the water around them and eventually suffocate. They will need his constant supervision for a little over a week until they hatch. The sandy colour of the messmate pipefish allows it to blend in perfectly with the ocean floor. It has a long, pointy mouth to help it suck up small crustaceans and plankton. In the waters of the Philippines, these banded pipefish are often found in male and female pairs. Along with other seahorses and pipefish, it is the male banded pipefish that carries and gives birth to their young. The female deposits her eggs into the male's pouch under his tail. Then, after a month of incubation, the male will give birth. All of the bottom dwellers we've seen have good strategies for staying hidden. But perhaps the greatest ambush predators on the ocean floor are species of flatfish. Like the angler flatfish and the peacock sole, who can creep beneath the sand protected from predators. Their grainy bodies, when motionless, make them almost invisible. The angler flatfish can use its eyes like periscopes, rotating them 180 degrees to track its next meal. And a peacock sole can make a surprisingly quick getaway. When it comes to camouflage in other areas of the seafloor, the challenge is to resemble not sand, but multicolored stones. This is not a problem for these little dragonfish. Encased in their bony armor, they have long flattened snouts and wing-like pectoral fins, which they use to pull themselves along the bottom. Little dragonfish are extremely well camouflaged. Their natural colouring and patterning makes them look just like pieces of shell. They are also able to fine-tune their colours to blend into their environment. The wing-like pectoral fins of the males have blue and white margins, which they can flash to deter predators who get too close. From a distance, it's hard to imagine how you would spot the little dragonfish at all. Understanding the role of colour on the reef requires perceiving the underwater world through the eyes of its inhabitants. What we humans perceive as attractive, camouflaged or not, is very different from how these fish interact with one another. Marine biologists are only now beginning to understand the complex language of colour. Thanks to behavioural studies and new technology, scientists are starting to unravel the secret codes behind the colourful surface of this underwater world. This includes the best-kept secrets of some of the largest creatures who live on the reef. The whale shark, the largest fish on the planet. These enormous creatures are around 25 feet in length and can weigh up to 15 tons. Whale sharks have a distinctive pattern of light-coloured spots and stripes on their backs. These spots are scattered in a pattern believed to be unique to each shark, like a human's fingerprint. Each pattern of spots remains stable throughout a shark's lifetime. Like the spots on other marine creatures, they may act as camouflage, reflecting and dispersing light to deter predators. But as whale sharks have so few predators, some scientists have suggested other reasons for these patterns. It's possible these spots may help shield the sharks from the sun's radiation, as they spend a lot of their time hunting for plankton and fish near the surface of the water. Despite its enormous size, the whale shark feeds almost exclusively on plankton, eating over 20 kilos a day. Whale sharks are often solo swimmers, but here in the Philippines, they're sometimes seen schooling with their brothers and sisters, where food is particularly abundant. Whale sharks are an endangered species. The population has decreased by over 50% in the last 75 years. The greatest threats they face are not from other fish, but from us. Toxins from plastics in the oceans, poaching, and entanglement of whale sharks in fishing nets all threaten their very existence. To monitor the population of whale sharks, researchers often use their unique spot patterns, allowing them to keep an eye on individuals and to learn more about how to protect this gentle giant. Coral reefs themselves face a number of threats to their survival. Over the last century, 50% of our reefs are either dead or in a critical condition. Yet our understanding of colour and camouflage is helping us to protect keystone species like whale sharks and turtles. Reefs are some of the most fragile ecosystems on Earth. A rise of just a few degrees to the ocean's temperature can lead to widespread coral bleaching. The coral jettison their plant cells, and if they're not allowed to recover, the beautiful colours of the ocean's reefs will vanish for good. With many coral reefs on the brink, it has never been more important to understand how these ecosystems function. What is clear is that the world of colour and camouflage beneath the waves needs our protection as well as our understanding. From shallow reefs to the ocean floor, we've seen how colour and camouflage shape every aspect of this underwater world. It's a world constantly moving in a kaleidoscopic dance where every flash of colour and every pattern has a purpose. To hide from predators, to identify individuals of the same species on the crowded reef, to help marine life navigate thousands of miles, or to find a mate. From sea anemones and the coral itself to dangerous invaders and venomous marine predators, we ignore the language of colour and camouflage and what it can tell us about marine life at our peril. In learning the hidden meanings behind the beauty of our planet's colourful coral reefs, we are also learning how to preserve them for generations to come.